Okay, let me go back to 1. This one? No, that's not it. I'm trying to find the one where the kid walks. That's the one I'm looking for. Where is that one? Okay. Ah, there it is. So this one is a little bit strange. So let me kind of go through it. The strangeness comes about from the fact that I think this one is the one that has a funny air curve associated with it, related to the angles. So it says a brother and sister are playing in the woods. When the brother realizes that they're separate, the last place he remembers is in a particular large tree. The brother has traveled D1, which is 24 meters, at that. So, okay. Now I'm pretty sure there's probably everybody has different things, but here this is 24 at 24.5 degrees. Okay, that's where he traveled. Okay, the brother traveled distance 1 at that. From the tree, I guess I'll put a T right there for the tree. And then turned and traveled D2 or 10 meters at 139. Meantime, the sister traveled D3, which is 17.5 at an angle of that, which he said he's saying minus 112. Now, kind of depends on the way you kind of look at things, because it's kind of strange. So to me, I see this minus 112 as relative to the coordinates, so I would see that as being 112. And then he says the angles are given. Okay, hang on. With respect to east, with counterclockwise being defined as positive. So it's kind of weird. So here's his north. Okay, that's south. And this will be west. And there's his east. And he's saying clockwise runs this way. So he's saying this is positive. So that's his minus 112 thing. So this is part of the thing that you have to kind of be aware of with this. And he may actually hold you to some of that. As far as the angles go. Then he said, he does all that, he gives you all that. And then he says, use the parallelogram law to add these vectors geometrically and determine the displacement of the boy relative to the tree. You know, it's true he's asking that, but by the same token, you can come up with the answer without using the parallelogram law if you break it into XY coordinates. He's asking you to do something that you don't necessarily have to do to get the answer. So it's up to you whether you want to do that or not. That's kind of up to you. Then he says, express your answer separated by a comma with 2, 3, 6. Enter the angle measured counterclockwise. Okay, this being clockwise, that being counterclockwise, from the positive x-axis, which is the same thing that he was saying up there is the east thing. So from the east, so, okay, so that's fine. So then the thing is okay, what is he looking for? He said displacement of the boy relative to the tree. So all you're doing is adding this vector to that one. Depends on how you want to do it. You can do the parallelogram law and find that distance. You know that, and you know that. You know this 139. I've kind of got this drawn kind of tiny. But I can draw it bigger up there. Maybe I'll do that in a second. So you know you got the, was that 139? Yeah, it's 139. So maybe I'll draw it a little bit bigger because I can take it away in a minute. So here he's got this movement, which is 24.3. And he's got this distance, which was 24. And then he's moved this distance, which is 10. And it is 139. So here, let me kind of move the 24s around. I'm not sure I did any better here than I did over there. So what you're looking to do is kind of go up here. So you got a triangle, you got this side and you got that side. The question is, can you get that? Because if you can do that, you can jump right across there using the law of cosines to get that. There are other ways to do it too, but if you want to do, and maybe on the second part we'll do something different, but on the first part we'll just try to do this. So the question is, what is that? Okay, first, if I take this line, and let's see, this line is parallel to that line. So the question I would have to ask myself is, what's that angle? Well, how do I do this? If I drop that line, and I move that line over to here, and then I take this same line, which is right here, this is kind of looking weird. And I take that line, this one's opposed to here, so that's 24.3. And I don't know what 90 minus 24.3 is, but I'll just make things easy for myself. If I'm going to write a number on the board, it'd be good to have the right number. What? That was weird. So 65.7. So I probably should have known that. Now if I got that angle, okay, this line is actually, it doesn't look like it, but it's the same as that line. And this line's the same as that line. So this would be 65.7, and that's 90. So now, if I zooped all the way around and took 360 minus 139, which is that, minus 90, which is that, and minus 65.7, which is that. Let's see. I think it could do that. It says that is 65.3. And I'm assuming that this thing, I don't know. It looks like it got the right numbers off the board. So if that were the case, then you got the law of cosines. And, c squared is equal to a squared plus b squared. If it is an angle of 90 in there, you can stop there. But if it's not, 2ab cosine of, well, usually it's written as a little c, but some mathematicians want to write it between the angle between a and b. And that's okay. So, if you don't mind, I might, hang on a second. I'm going to check and see if this is an unrelated item. I thought I would see if my package arrived that that's sad, isn't it? Okay, hang on, I'm pushing the wrong buttons. Okay, let me do this again. Oh, it's still saying that the thing's moving. That's really weird. See all updates. Now it's looking different. Oh, okay. Package was delivered at my house. I should go quickly and get out of here. So, if I want to know this side and call that side C, I can say the side is equal to this side, which is 24 squared plus that side, which is 10 squared minus 2 times 10 times 24 times cosine of the angle between that line and that line, which is 65.3, and I got to put a degree up there. Just see what this thing tells me. I don't know. It may pick up that. It says C 21.80422. Now the problem is it wants to know, oh geez, now I gotta have this angle. So now that I know this is 21.80422, I can go in and find that angle from law of sines. That angle over that is equal to that angle over that. So in other words, sine of what we're looking for, which is this one, over the thing opposite to it, is equal to the sine of that one over the thing that's opposite to it, 21.80422. So now if I multiply times 10, and here's the thing, I think to do this right, it wants to know arc sine of that becomes the angle. Let's see if it does that correctly. I think I had troubles with this before. Oh, okay. 16.62. Now, he's claiming that this is positive, and that's what he wants this thing as. So my answer should be 21. How many 3 significant digits? Okay, so that and 16.62 plus 24.3. I should be able to do that. Let's see, 2, that gives you 2. 6 is 9. That's another 1, and that's a 3, so that's 40. But he doesn't want that. Let's see if that's what I enter there. Oh geez, I need my glasses. 21.8. And then he says a comma. I'm guessing it's a comma. I don't know how this thing will read that. I guess it reads it as a string. 9 attempts left. So 21.8 and 40.9. So you know what I'm going to do? Wait a minute. Isn't there a thing that says answer. He doesn't want units because this is weird. This is not. Oh, meters and degrees. Okay. Let me just see if there is a way to push. There's got to be multiple buttons. If I push previous answer, that doesn't get me anywhere. A solution view. What does that get you? $49, 21.8. I got 40. Did I add wrong? I may have added wrong. What happened? Oh. I may have added wrong. Did I add that wrong? 616. So somehow this part got goofed up. Oh. It took the sine of 65.3 radians to get that. Okay. Let's see. That's going to be hard for that thing to see. Okay, so I'll do it again. Arc sine. It may not like that. Arc sine of 10 times the sine of 65.3 degrees over 21.80422. Let's try that. Yeah, it did that. I don't know if it's even going to be able to see this. Okay, let's see what it did. It says 24.62. It says 24.62. So if I add that 24.62 to 24.3, get 2, 9, 8, you get 48.9. Or if I'm supposed to carry that many digits, that's what I'm supposed to do. 48.9. So if you're using 48.9. And so now what happens? Okay, so if you're going to use that photomath thing, it wants to see a degree there. If you don't put anything, it considers it radians. So then the next thing he's asking is something about the distance between the boy and the girl. And so if you've got, okay, so we finished this part. If you finish this part, you could redo this to the point where you could say to yourself, okay, let me make sure I don't delete the information I need. So in other words, there's where the boy is located. The boy is now located 21.8. Okay, let me make sure I can read my own writing. 21.8. So he's 21.80422 up at 48.9, and that's from here to here. The girl is still, and I'm not sure that I've got the angles right, but it's 112 and 17.5. Now, obviously I'm going to have to move this off. And I'm not sure whether this is up here or below here. Could be up here, it could be below there. I don't actually know. And so that's something you're going to have to look at, is to tell whether it's this up here or whether it is, okay. Let's say this, and let's say it's down here. It could be that it's down here. So that's the problem you're going to face. Are these off each other or not? And one of the ways you can do it is 112 and 48, that's less than 180. So already I drew that wrong. So these are like this. Okay, so because 112 and 8.9 is nothing, 9, that's 5 makes 6, and 10. So that means this is 160.9. And since it's less than 180, it's collapsed this way and not that way. So sorry about that, but you got that. You got 21.80422 and 17.5. And using a method of vector addition, determine the displacement of the boy to the girl. So at this point, we can just do law of cosines off it. And since I drew this the wrong way, I'll stick to it. And it could be that yours folds out the other way. In other words, it could fold up here. It just depends on your numbers. And I think this was a situation where some people's folds one way and some people's folds the other. And then now you're looking at the same thing, c squared, or do like I did over there, okay? C is equal to the square root of a squared, which is, I'll just make this 17.5 squared plus, okay, if I'm going to do this, I need to make it legible. C is equal to the square root of 17.5 squared plus, I'm going to just take 21.8 squared minus 2 times 17.5, 21.8 cosine of 160.9 degrees. And let's see if you can recognize that. And well, let's see if it recognizes. Let's make sure. It says 38.76. Oh, geez, he wants an angle too. Ah. Okay. Now, know this is 112, so here's the problem. I gotta find, okay, so here's the problem. Okay, so he wants to know the displacement from the boy to the girl. So that means this vector goes this way. From the boy, so here's the boy and here's the girl. From the boy to the girl. So what the dude really wants is the angle to there. So now, what is the most convenient way to get that? Well, the first thing I can do is just haul off and try to find both that angle and that angle, and that's what I'll try to do. And so, I'm going to try it. First, I'm going to just do sine, how about I'll do the sine of the little g for the girl, and then the side opposite to that is 21.8 equals to the sine of the boy, and the side opposite of that is 17.5 equals to the sine of the 160.9 degrees. That's this one. The side opposite of that is your 38.76. So let's think about this. Which one is the most convenient to actually know? So I've kind of, oh no, I don't. Did I kind of delete a lot of it? Okay, so I have a vector that draws to the boy. Okay, wait a minute. Okay, so I'll use this. It draws to the boy, and it is, okay, I'm losing a lot of my information. So it is, okay, so this is my center spot. I draw a vector from here to the boy, from there to the boy, from here to the girl, but shoot, I hate that. So hang on. I'm going to try to do a decent job of putting this together to get a couple angles so I can add some. This is 48.9 and it's 21.8. It's the 21.8. There's the 48.9. And the girl is off here at 112. 17.5. Yuck. All I need to do is I need to find, actually I think if I just found this one, I could work off of that one. That's this one. And that would be, let's see, where could I find it? Arc sine of 17.5 times sine of 160.9 degrees over 38.76. And I think that's all I need. Okay, so let's see. Let's move this up here. Let's see if I can get that little tiny angle there. No, might not get all that. I think it did. We got that angle B as being 8.5 degrees. Just kind of makes sense. Really, really tight sliver. So now the question is, where do I go from there? This is where the angle part is the part that figure out this thing. So if you're at this point and you sweep up to here, you're sweeping up 48.9 degrees, and at that point you need to sweep around. Okay, so he's wanting to know this angle. So if I sweep around to this angle, what would I be sweeping around to? In other words, let's take a look at this. That is 48.9 from here. But if I'm going to do that, I'm going to sweep all the way around to here. What am I sweeping out here? These two angles. So in other words, if you're measuring up from here, it's 48. Okay, hang on. If that's 48, and that's got to be 48, and that's 180 plus 48. But then I got to sweep another 8.5. Let's see, 4, and 16, 17, 237.4. Now, and that's I'm a little queasy about that because for a couple reasons, but I'm going to put it in, see what happens. But I need to know first. Okay, that's the 38.76. Or maybe I can just hit well, I'll put it in this way. Because if I get part of it wrong, here, I'll just do this. I don't see 21.8 meters. Wait, and 49.1. Okay, so see, this is 21. I got a different answer than he does. I think distance to the void. Wait. dB. I don't know what that is. 21.8. I did not wait. 21.8. Oh, I'm sorry. That's 0.8. Sorry. Okay. 38.8. 38.8. So he says 238. So I got 237. But I think he also accepts that. So he accepts the minus. Also accepted is that with a minus. So he should accept that as well as the 238, which I got 237.4. So that's the key. At least he allows the exception of that. So let's see, 2 and it has to be 1, 3, or 6. That's 360 degrees between these two. So it should accept both of those. It says. If it does not, and I think there was an experience previously where it did not, even though it says it does, just take the 360 and subtract off of it and put in the positive one and then try to put in the negative one. So that is a long problem. That is, but it is just simply vector addition. So let me see. Okay, let me see if this other thing. Okay, just out of curiosity. 935. What about the other one? Oh, they're both. 935. You know what? I mean, I may. Is this okay? Because I might let us go early and go put those off my front porch and then arrive back before fluid starts, if y'all are okay with that. Because I just don't want people to. I don't live in a bad neighborhood or anything, but. So I think I'm going to